Now let's take a look at the third topic of interest. How do I solve absolute value inequalities? And more specifically, how is it that an absolute value inequality is able to determine an interval? Well, let's go ahead and take a look here at something like 3a. And I'll do this work down here. I'm actually going to go ahead and kind of section this off over there just so we don't get in the way. But here I see that I have an absolute value inequality of absolute value of x minus 3 is less than 1. And again, the goal here is that I would want to be able to figure out what are all of the different possible values of x that could make this work. So for example, if I tried certain values of x, maybe say I tried the value 0, I would see that if I plug 0 in for x, this left side of the inequality would become absolute value of negative 3, which is 3. And then it would say 3 is smaller than 1. Well, that's clearly false. 3 is not smaller than 1. So 0 is not a good value for x. It doesn't make the statement true. However, there are some values of x that would be great. What if I use something like 3.5? If x was the number 3.5, then 3.5 minus 3 is just a half. Absolute value of a half is still a half, and a half is less than 1. So if I use something like 3.5, I get a good value of x. It makes the statement true. But I want to find all the values of x. And very interestingly, those values of x will ultimately determine an interval of x values. Now, in order to go ahead and do this, it's important that we're able to think about how to solve this absolute value inequality. And the best way that I know of to try to think through this is to, instead of focusing on numbers that I could plug in for x, instead I'm going to focus on the fact that the inside of my absolute value bars will have to become a certain value in order to make this statement work. So notice right now I'm not thinking about what I'm going to plug in for x. I'm thinking about what the entire x minus 3 could become. And what would I need it to become in order to get the result, when absolute valued, less than 1? Well, if you think about this, you could say like, well, wait a minute. If the inside here was something like 0, that would be perfect. If the inside here was a half or a seventh or 2/9, all perfect. Because when I absolute value those numbers, I automatically am going to get a result less than 1. So from this, I can easily see that the stuff on the inside could be less than 1, and that would be great. However, I can't just use any value less than 1 in here, because if I was to put in a number, say like negative 2, that is, if x minus 3 turned into the value of negative 2, then when I absolute value, I would get a 2 on the left side, and 2 is certainly not smaller than 1. So how low can I go here? Well, what we'll see is that I have to pick a value that's between negative 1 and positive 1. Right? Those are the values that can go right here, so the result ends up less than 1. Now, the question is still, what values of x do I need to pick so that this inside can come out between these? Well, notice this is actually just as simple as rewriting in what we had up above. I need the thing that was on the inside of the absolute value bars to be a number between these bounds. And so by simply solving this inequality by adding 3 to each of the sides, I can see that I am going to need x to be a value from 2 to 4. Or I could write that as an interval 2 to 4 using parentheses. So this is the basic idea here. I have to get the absolute value less than something, and then I'm interested in how can I make that or what do I need to make that inside into in order to get this to work? Again, I have a couple more examples in parts B and C up there for you to try, and of course the solutions are posted up in Blackboard.